O, dobrze. Cześć wszystkim, nazywam się Hubert. Będę mówił po angielsku, bo wciąż są kilka osób, które nie mówią po polsku. Mam nadzieję, że to jest OK. So I'll switch to English. So my name is Hubert Łępicki. I'm from Warsaw. I'm the owner of Hubert. We're a small Rails consulting company from there. And I'm going to be talking about JRuby and Torquebox. So JRuby is JRuby and Torquebox is an application set. So we all know what Ruby is. We are all Ruby users. What is JRuby? JRuby is Ruby implementation on top of Java, on top of Java virtual machine. You guys can hear me, or should I use the microphone? It's okay. It's okay. Cool. So it's Ruby implementation on top of JVM. It supports 1.8 and 1.9 syntax already. I think there's work being done on supporting 2.0. I'm not really up to date. It is cool, including requirements. That's tricky.
Parts of the compromise.
Okay, cool. It's actually very compatible with the Ruby, with the MRI like implementation. I haven't found an example that it is not, after using it for a while already. It has real threads, so unlike Ruby, where we have this global interpreter lock that comes into our ways from time to time and just blocks to the single thread. JRuby uses real operating system level threads, so we can do concurrent work within the same process easier, and it actually works on Windows, and works fast. So if somebody had a crazy idea of deploying Ruby app on Windows, you can do that. Rails on JRuby actually works fine. So Rails itself is, there's no problem in running Rails 3.2 on JRuby. There is a little problem that I found recently on running Rails 4, which hasn't been really released yet on JRuby because of active record adapter. That I was basically not able to run migrations. You can run the app when it's running, but I was not able to run migrations. I think there's work being done on updating JDBC driver for active record. But I use JRuby with 4.0 application that's using SQL, and it works absolutely fantastic. The problem with JRuby that most people know of already is that C extensions is that they don't work. That's actually not true. A lot of C extensions do work on JRuby. C extensions are disabled by default. In JRuby, you can enable them. But it's not the way forward. The old style C extensions in JRuby are just passé, so you should not be using it. Instead, you should be using FFI, which stands for Foreign Function Invocation or interface, I don't know, which is basically a way to invocate C code from Ruby code. In my experience, it works great with C code, but it doesn't work very well with C++. So with C++, there's weird voodoo things happening, and I found myself writing little wrappers around C++ libraries in pure C, and then using FFI to bind them. That was actually what I had to do to use C++. Some C++ libraries I was depending on. What it really means for you, for your Rails application, is that you should not be using gems like AirMagic, for example, because it depends on C++. ImageMagick library. Some of the gems we have to replace with their variants for JRuby. For example, Postgres gem. There's a JDBC Postgres gem that we have to include. There's also different JavaScript runtime that you can use in JRuby, which is Java has this Rhino engine. But if you're using the eraser, you can replace the gem with the Rhino, and it should walking. Some of the gems, some of the extensions are not necessary. Like, for example, for Mongo, there's MongoX gem, which is not necessary on JRuby. You can skip this one. And the Mongo gem should work just fine. How do we migrate our application to JRuby? I think the best way to do is to first, still being on the MRI, get rid of all the C++ incompatible dependencies, run the tests, our app is running, deploy it, it's live, fine, and only then migrate to JRuby. If you try to migrate your application to JRuby and update their dependencies at the same time, you might find yourself in a big mess. Just too many things to fix. You should enable common thread safe in your production RP if it's not already enabled, because you can use threads, which also you should make sure that your application is actually thread safe, because Rails probably is, but your code can be not. You should install JRuby, run bundle, replace your RDMRC, and that's it. You can start developing, running your application. But that's not all what JRuby can offer you. Not only thread safety and running development on WRUG on JRuby. You could exploit the environment of Java to power up your Ruby application. For example, you can deploy JRuby applications on top of Java web containers or application servers. For example, there's a gem that's called Warbler. You can pack your Ruby application into War archive and deploy it onto the, I don't know, Tomcat container or some other web containers. There are different multi-threaded web servers that you can use safely on JRuby. For example, a good one is Puma. All you need is a web server. You don't need any background jobs. You don't need any services, or you can manage to do it the old school way. You can safely replace a lot of unicorns with a single instance of Puma web server. But if you want, you could use advanced application server. I'm going to talk about Torquebox to replace a lot more of your system level dependencies or your Ruby dependencies with pre-built architecture from the application server. Like, for example, you can get rid of the queuing system, rescue if you're using it, Chrome, or even you don't have to have Ruby or JRuby installed in the system. It can come bundled with your application server. And you can also use Java monitoring tools, which are okay, and profiling tools, which are supposed to be great. I know you didn't use them. To profile your Ruby application. The second one I want to talk is Torquebox. This is Java. This is actually Ruby application server that's built on top of JBoss. And if you know JBoss, you probably have this thing in your head that says slow, starting slow, huge amounts of RAM being used, right? Actually, Red Hat put a lot of effort recently to developing JBoss, and they slimmed it down. So, having in mind the recent developments in terms of really Ruby Rails applications, it's nothing scary anymore, I would say. So it's built on top of JBoss, and it's built on top of JBoss with Ruby extensions. And it's also developed from Red Hat, so the same guys that developed JBoss. So they're supposed to know what they're doing. But let's ask the question, what the hell is application server? Because we know web servers, we just start a bunch of unicorns, that's the web server, then we have some queuing system, then we have some demos, Unix demos running in the background. But the application server is something more. It's something that you're supposed to run the whole application into this environment. So it provides you an architecture to run not only web part of your application, but only run your queuing or your background jobs, or to run your Chrome, within the same as a container. So it usually contains a multi-threaded web server, environmental and background services, messaging. Tokbox has JRuby environment built in, so you don't have to install RPM on your system. All you have to do is unpack and install the Torquebox on your server, and the JRuby will come bundled with it. And on the same application server, you can deploy multiple applications. So you can specify that the main application will deploy at the root, and slash up to I will deploy some other application. The configuration is quite flexible, so you can amend them as you want. Torquebox comes with a proper web server, layer for running services, which are equivalent for the demos on the Unix. It comes with scheduling module. Scheduling module is equivalent of the cron jobs. It comes with messaging, so message passing queue. I'm going to talk about it in a second, which you can replace your REST queue or ZOM queue, whatever you're using, with Torquebox infrastructure. It also has support for clustering and load balancing, and it has a thing that's called stamplets, which basically is a layer on top of WebSockets that provide you direct communication between the JavaScript clients and your Ruby backend application. I have used in production all of those except stamplets, so I'm not going to be talking about them. If you want to learn about them, you have to investigate yourself. One of the things that you have to add to your application when you want to use Torquebox is the deployment descriptor. This is a file that describes the infrastructure that Torquebox should provide. You just dump this file into config torquebox.rb, and you specify different context this is the configuration of the website. So what I find myself doing is to have different configuration for different machines. So if I'm developing, I have different deployment description for my development, but if I deploy to production, I have a bit different, a bit tweaked, a bit optimized version of it over there. It looks like it. I'm gonna refer to the parts of the code later. But you can see that it defines different sections. There's a web section that specifies where your app should be deployed on the JBoss. I'm just deploying it to the root. There's one service being run. The service is basically a root class that you define. There's one job which is equivalent for running the cron job. We don't have to use whenever anymore.
Excuse me, if you want to step on the stage and just show the lines, then just go on.
I think it's fine. And I have two queues defined. I have one topic, which is like a broadcast queue that you can broadcast messages to multiple clients. And I have one normal processing queue, messaging queue, that when you process the first available, when you post the message to the first available client will process the message. In your gem file, you have to add a few gems. So 4 gems, but if you're not using some of the functionality like stamplets, you can easily remove it. If you're not using messaging, remove it. That should be fine. The second gem, Turboserver, is also optional. This gem is pulling Torquebox application server packed as a gem, but you can just unpack the tar, download it from Torquebox and install it. That will work as well. Run bundle, it should fetch all the dependencies. The steps look like it. Install Torquebox, run Torquebox. That will actually eat the current console, so we have to fire a new one. Go to your app, dump Torquebox RB, edit gem file with the previously mentioned gem. And the thing you do is you don't start your app with Rails.s. You deploy it to the local instance of running Turboserver with Torquebox deploy. That will put a configuration file into the Torquebox environment. That will point Torquebox server to where your application is locally installed and will start your application in development mode on your local machine. Development mode is a bit tricky because, as you can see here, over here, I have a web context defined, which is going to be subject of normal arrays class reloading. That's going to work just fine. But for example, the services will start in a separate process, I would say, and they're not going to reload. So if you're making changes to your services, you have to restart, redeploy your application actually. So you have to run the last step, Tokbox deploy again. About the services. Services are pure Ruby classes, which is great because you can test them independently from your Torquebox installation. They are normal Ruby classes that you define in deployment configuration. They should respond, the interface is quite simple. They should have initialize methods with options. Options you can pass from your application deployment. For example, I don't know, if you're using some web service and this service should be using it, you could pass an URL to the backend, for example, here. And they have to respond to start and stop methods. That's the life cycle of the service. When the application boots, initialize method will be called. After that, start method will be called. You are responsible to start a new thread, and you're responsible to finish the new thread. So if you're doing some processing in a loop, you should periodically check whether your service should not be stopped, or you can kill the thread if you don't care. Jobs are even simpler. They just have to respond to run method, and you define in the Torquebox RP with simple cron statement, as well as the services. The jobs will run within full Rails environment. So despite the fact that these are normal Ruby classes and you define them in the configuration, they will run in a full process of Rails application. So all the models or your dependencies will be available to them. Low-level messaging, if you want to use bare-bone low-level messaging, is also quite simple. We're actually using it because we found Tokbox also provides some abstractions that are supposed to make it easier, but it was not flexible enough for our needs, so we fall back to the bare-bones processing, but it's actually quite easy. You just specify which queue you want to use, and either publish a message on it, that can be a Ruby object, or you receive it. There are also methods to check whether there's a new message waiting for you on the queue. To filter the messages, you can filter it with a SQL-like language, so you can filter for some message that has some attribute, for example, if you pass a hash and check whether it's waiting in the queue. And if you do the queue receive, then you will receive, then your thread will wait for a message and read it. So this is the bare-bone processing, but we found ourselves in need for something that's a bit higher level abstraction. So there's another entity which is job processors. So Tokbox comes with one predefined job process, which is the background table processor, but we wrote our own. The interface is just absolutely idiot-proof. You have to respond to on message, and in your Tokbox configuration, you just specify to which queue your processor applies, and you specify concurrency. So how many workers, basically, should the Tokbox application server spawn to process those messages posted to this queue? Easy enough. If you want to make those, by default, those messages will not survive the server restart. So if you kill your Tokbox or you restart your application, your server, the message queue is going to be emptied because it's being kept in memory. But you can add durable true option. Then all the new messages are being written to the disk first, and they're not going to be removed when you restart your application. Okay, so let's have a look at the deployment descriptor again. So it provides different. It defines different contexts for your application. It provides a service. There's another job. The messaging queues, messaging processor, and the web context, right? Now, where exactly they are being executed? Within Torquebox, right? But is it the same process? Is it the same thread? How do you define that? You can put another section in your application descriptor. Where was I? Here. Basically, you define pools, and there are two kinds of pools. There is a shared pool, which means everything defined within a shared pool is gonna be run within the same process. Basically, just one Ruby interpreter being started. And if you define a bounded pool, you can define minimum, maximum amount of processes, basically full Rails instances being loaded. This is going to be executed in, I would say, separate process. So what is gotcha is that when you're using the shared pool, you could, for example, this is the same process, so you could use nasty stuff like global variable that holds some state information, and the other threads, the other processes like services will have access to the same variable easily. The other thing is you probably shouldn't be doing that, but if you really do that, define a shared pool. A bounded pool will eat up much more RAM initially, but if you have some concurrency locking, if you have some mutexes or stuff that has to be wrapped around critical sections, then you can just start different processes as a bounded pool, and they gonna interact. What's the best way to interact between those services, messages, and other instances? Is the queuing. So you should send the messages. Tokbox has this interface pretty well defined, so you can communicate without using global variables, for example, or class level variables. Another abstraction that is something like sidekick or delayed job. Tokbox provides us with background jobs. Usage of it is simple. In any Ruby class, that could be active record module, whatever, you include Tokbox background label, and you can either call every single method with my class dot background dot my method that's going to execute in the background, or you could define always background method name. And if you use this macro, which is called always background, then all this method, every time it's going to be called, it's going to be executed somewhere in the future. Now, how do you monitor the status of execution of the method? Basically, you're going to be returned the future variable, variable, let's say, that has the value. If you do the future value, that's going to be the return value of the method, but it's going to wait. You can also check the status of the completion of the task, so whether it's pending, whether it's executing at the moment, or whether it's been completed, whether there was an exception raised, etc. So the futures are the way to go. We find that it's awkward to store these future variables into the main thread of web application. So we decided not to use it and fall back to normal messaging. In my experience, these future variables are also not very reliable. So we had experienced that situations where there was an exception raised in the background job, and the future still thought that this is all fine and it's executing. So Tokbox users say that you should use background label for stuff like sending an email, confirmation email message, for example. Stuff that if it fails, it's not critical. If it's critical, you have to follow up to some more advanced message processing. You can configure a background label as well. So, how many threads execute the background jobs? You just dump that into the config Turboserver. This is another variable that I like to change when I deploy to production. On production, I have more powerful systems than on the staging, for example, so I can safely increase the concurrency there. And some gotchas. If you decide to use Torquebox or any other application server, you're basically adding a new layer of infrastructure. And this layer of infrastructure can change in time. There can be a new release of Torquebox. It also can be a buggy. There are some bugs in Torquebox, let's be fair. And there's also some nasty code in Torquebox, for example, integration with new layers, just like that. The other problem is zero downtime. So if you, this is fun, because if you ask Torquebox users whether Torquebox provides you zero downtime, they will say, yes, it does. No, it doesn't. It provides you a thing that's called hot deployments. So you can deploy a new version of the application to your JBoss, to your Torquebox, without restarting the whole JBoss Torquebox application set. But there will be a time that the app is down. So if you require zero downtime, you should be using clustering, at least 2 nodes of Torquebox, and deployment that deploys first to the A node and later to the B node. Only then you have zero downtime. That's perfectly doable. Not that easy, but it's also not a rocket science. So you have to take care of that yourself. You're also responsible for shutting down your services. That's the thing we learned hard way. If you don't stop your service properly, you respond to the stop method, they're going to stack and pile up together, eat your whole RAM. Then you're going to think, oh, the Java crap is eating all my RAM again. But no, it's actually your fault. Background label, limited use. They're good for sending emails. They're very good for stuff that takes less than 30 seconds. After that, there can be some timeouts. For example, your future variables do not behave properly. We had a problem with race concept. So Torquebox provides some gem that you should still be able to run race.c and your console should start. But we found it buggy, and instead we're using web console. So basically, there are a few gems. One is for Torquebox that you can launch a console from within the web interface. It's not perfect, but it works. And for me, the most important thing is to keep our application logic separate from the infrastructure. We have a layer of infrastructure that's Rails. If we're depending on that, I think that's enough dependency on the infrastructure we have already. Let's not add another dependency in Torquebox. So I find myself wrapping my classes that do some logic. If there are services around Torquebox services, so I have, for example, Torquebox crawl job that wraps the crawl job. That's also important to have this separation between logic because, for example, for services or messaging, you can stumble upon a situation that Torquebox wants to serialize a class. So all the classes you define in this application descriptor should be just basic plain Ruby classes that can be serialized. So my service should be serialized. My recurring job should be serializable because that's what Torquebox is going to use. So if you want to, for example, define instance variable that's a thread, no, don't do that. Because you're going to run into trouble. And you can monitor your app with JVM monitoring tools. There's a gem from Tokbox thing that's called Backstage that provides you insight into the queues, for example, that are running. It's like the rescue. Rescue has this web interface gem that you can preview what's going on in the rescue queue. Tokbox has something that's called backstage that you can see what applications are deployed to your Torquebox instance, what are services deployed, running, what's happening. You can also use the logs. That's something I forgot to add to this presentation, and I'm just remembering it now. You can replace your race logging that writes into the files with a bit more advanced Torquebox logging that writes to the Torquebox log system, and then you can use various JRuby-specific tools to browse, archive, read those log files. So this is another advantage that you can have by using Tokbox. I think that's it from my side. I'm waiting for questions.
If you have questions, go ahead. They can be in Polish, I guess, if you
Yeah.
So,
Tomasz.
so if I open up the web console and open up the class where the final method, does it pollute the web application environment?
If you're using the shared pool, yes.
So, for you particularly, or for the projects that you used JRuby on, what was the original motivation for going the JRuby way?
Okay, the motivation was that we're having an app that is not really CPU intense. Basically, what it does is crawling web. So it downloads a lot of files from the internet, graphic files, websites, whole websites, filters, etc. In theory, that should not be CPU intense process. There's a lot of I/O going on, but we found ourselves 100% CPU usage while using that and the rescue and some demos. So Tokbox actually helped us a lot by reducing the resources, especially CPU, but we had a lot of RAM on the server, so we didn't bother about looking at the RAM. But now if I look at the RAM usage, there's plenty free, while previously it was running low. So we actually reduced the server usage. We need less RAM.
Would you now consider, when starting a new app, starting from scratch with this set?
It depends on the app. Because the initial overhaul is quite good, quite big. There are some problems as well. So we spent, I don't know, a week investigating Torquebox, trying to port our existing app to the Torquebox until we found out how we do it. But so if I'm building a new app that's gonna have a couple of services or background details, we'll be using cron jobs and the web stuff, yeah, we're gonna use Tokbox.
So where do you host your Torquebox instance?
I think there is support on Heroku for Tokbox already, so you could deploy to Heroku. I didn't try that. We have a dedicated server for the app. Actually, these are free servers, and the Tokbox is fast.
Okay, if there are no more questions, then thank you very much. And thanks for coming all the way from Europe. Thanks. The next talk, which will start in a couple of minutes, is going to be in Polish, so if, but the slides are in English, right?